The horticulture students at Omaha Northwest Magnet High School participated in the Samsung Solve for Tomorrow contest to showcase our STEM skills to solve a local problem by engineering a rain garden on our campus.
In Omaha, our storm drains and sewer systems were combined when they were built. As the city grew, soil has been compacted, vegetation has been removed or altered, and impermeable surfaces like pavement or buildings were installed, all contributing to excessive stormwater runoff that degrades the local environment. In a recent year, we had 39 inches of rain, which equates to 52 billion gallons of untreated stormwater. As little as 1/10 of an inch of rain creates enough volume for the combined sewer system to flood into people's backyards, creating a major concern in aesthetics and safety. To alleviate this problem, we are building a rain garden on our campus. A rain garden is a shallow depression in the ground composed of native plants that collects and absorbs rainwater and filters pollutants out of stormwater runoff. Many of the harmful chemicals that deposit into the nearby Papio Creek arrive via runoff. Notice the high amounts of E. coli, oil hydrocarbons, lead, phosphorus, heavy metals, and sediment. These captured pollutants can be broken down over time in the rain garden and removed through mulch absorption, thus reducing the Papio Creek and neighborhood water pollution.
To engineer our rain garden plan, we met with the University of Nebraska Omaha's Environmental Sustainability College Students through Service Learning. We then presented our initial plans to the public at UNO and to Nebraska Green Infrastructure Tour. Finally, we incorporated the best pieces of each proposal for our final design.
To plan our rain garden, we probed the soil to test soil composition. We found that we have silty clay loam in our first soil horizon, which is moderate draining soil. We also had to test the rate in which water infiltrated into our soil. We have to have a rate of at least 1/4 inch per hour to prevent standing water and mosquitoes. Using a soil infiltrometer, we determined our infiltration rate to be 1/8 of an inch per hour. Next, we measured the slope of the land to ensure that the bottom of the garden would be built evenly. To find our slope, we had to use a level on a string to measure the rise over the horizontal distance. As we designed our rain garden to scale, we had to include the areas of our rooftop and parking lots so we could calculate the volume of water our rain garden needed to hold. We decided to use native Nebraska pollinator plants that incorporate our school colors. We researched which plants could handle full or partial sunlight and varying amounts of water to determine what to plant on the bottom, the slope, and the berm of the garden. We chose pollinator plants such as milkweed, since we participated in the Monarch Watch program, where we tag monarch butterfly wings to monitor migration patterns and population numbers. Lastly, we designed our garden to have permeable pavement walkways containing plaques with QR codes that directs guests and students to our school webpage and informs them on the plants and the purpose of the garden.
Our rain garden construction will be completed by the spring of 2016. For future plans, the rain garden at Northwest will be used by science and math classes for data collection on plant wellness, best plants for infiltration rates, and types of pollutants absorbed in the soil with the hopes of a potential journal publication. Finally, we plan to raise awareness for our rain garden by hosting a community planting day.